Good day everyone. One of our topic is to discuss review on set theory. This topic, it has 6 types of set. 1. Finite set. 2. Infinite set. 3. The null or empty set. 4. Set equality. 5. Subset. And the last one is universal set. Later on, I will discuss these 6 types of sets and I will give an example. But before that, let us define first what is set. So set is a well-defined, finite or infinite collections of things, objects, or ideas. Order has no significance and multiplicity is generally also ignored. Members of a set are often referred to as elements, and the notation is used to denote them. Always remember, if an object X is an element of set A, we write this one. And if an object Z is not an element of set A, we write this one. And the number of elements in a finite set A is denoted by this one. So, the study of sets and their properties is the object of set theory. Always bear in your mind that the number 3, 6, and 91 that is called an elements or members. And these 3 dots that is called that the set is infinite. Note, lest each element separated by a comma and then put some curly brackets, it's around the whole thing. This one bracket. Now, let us discuss first the finite set. So what is the finite set? So finite set are sets that have a finite number of elements. Another meaning, a set with limited elements. Example, set F is the set of counting numbers less than 7. So, the element of set F are 1, 2, 3, 4, 5, and 6. So, the cardinality of set F is 6. Second type of set is infinite set. Infinite set is a set which is not finite. It is not possible to explicitly list out all the elements of an infinite set. In other meaning, a set with unlimited elements. Example, set N is the set of counting numbers. So, the cardinality is infinite. And the third one is the null or empty set. This is the symbol of empty set. Let's name it as set A. Another writing of set E is this symbol, which is the null. So, the cardinality of set E is 0. The notation simply means that the number of elements. The fourth set is called set equality. So, set equality, equal sets have the same elements. The order in which the member appear is the set is not important. Example, set E is the set of letters in the word earth. So the elements of set E are E, A, R, T, and H. Set H is the set of letters in the word heart. So the elements of set H are H, E, A, R, and T. So set E and set H have the same elements and they are equal sets. Example number 2. The elements of set R are 2, 4, 6, and 8. And the elements of set S are 2, 4, 6, 8, and 10. Since R and S do not contain exactly the same members, we say that R is not equal to S, and we write this one. and the fifth set is called subset. Set A is a subset of set B if and only if every element in A is also an element in B. Use the symbol this one to mean is a subset of, and the symbol this one to mean is not a subset of. Example, the element of set A are 1, 3, and 5, and the element of set B are 2, 3, 4, 5, and 6. This is not a subset of. Why? Because 1 is in A but not in B. Another example, list all the subset of set Q. So the elements of set Q are X, Y, and Z. So number 1 have 3 elements, 2, 3, and 4 have 1 element, 5, 6, and 7 have 2 elements. And the number 8 is the empty set, is a subset of every set. So how many subset does set Q? So we use this formula. So 2 to the power of n, which is n is the number of elements. So the elements of set Q have 3 elements. So 2 to the power of 3 equals 2 times 2 times 2 equals 8. The last set is called universal set. Is the set containing all elements and of which all other sets are subset. The universal set is represented by a capital letter U. Example, set U is the set of counting numbers. So, set A, B, and C are proper subset of set U because a universal set contains all the elements in a particular problem.
Venular diagram. So, what is venular diagram? Venular diagram is a picture that represents sets and their relationships. Consists of closed curves, the elements of which are represented by the interior of the curves. The relationships to be represented are overlap, containment, or neither. Venn diagram. Venn diagram represent all possible overlap permutations between sets. Venn diagrams are a subset of Euler diagrams, for they are the Euler diagram that represent all potential overlaps whether the sets have elements in common or not. Drawing Venn diagram. Determine the relationships between the sets such as subsets, intersections. There could be several ways to describe the relationships. Draw A within B if all members of A belongs to B, or A super subset B, or A union B equal to B, or A intersect B equal to A, or N parenthesis A intersect B equal to N A, or A overlap B if some members of A belongs to B, or A intersect B not equal empty set, or parenthesis A intersect B not equal to 0. Draw disjoint sets A and B if no members of A belongs to B, or A intersect B equals empty sets, or N parenthesis A intersect B equals to 0. Illustrative examples. Draw a Venn diagram represent the relationship between the sets. So equals A 1, 2, 3 and B equals to 1, 2, 3. Illustrative examples. 1. Draw a Venn diagram to represent the relationships between the sets. A equals to 1, 3, 5 and B equals to 1, 2, 3, 4, 5. So, solution, since A is a subset of B, step 1, draw a circle within the circle B. Step 2, write down the elements in circle A. Step 3. Write down the remaining elements in circle B. So, 2. Draw a Venn diagram to represent the following sets. Union equals 1, 2, 3, 4, 5, 6, 7, 8, 9. A equals to 1, 2, 5, 6, and B equals to 3 and 9. So, draw a rectangle and label it union to represent the universal set. Step 2. Draw circles within the rectangle to represent the other sets. Label the circles and write the relevant elements in each circle. Step 3. Write the remaining elements outside the circles but within the rectangle. Complement of a set. The complement of a set denoted by A is the set of all elements in the universal set that are not A. So this shaded area outside the represent A. So this is the example. The number of element A and the number of elements of A make up the total number of elements in union. Example. So this is the example below. So let union equals to x. X is an integer. -4 less than times less than 7. P equals to -4, -2, 0, and 2, 4, 5, 6. And Q equals to -3, -2, -1, 2, 3. So list the elements of set P. Draw a Venn diagram to display the set union P and find Q. So this is the solution. A, first out the members of U, and B, draw the Venn diagram to display the sets union P and Q. So this is yung example na may color, then I paste yung mga negative numbers. So find the Q. So use this is the formula. In parenthesis Q plus N, this is Q equals to N union, and Q equals to N union negative N parenthesis Q equals to 12, -5 equals 7. So intersection of two sets. The intersection of two sets X and Y is the sets of elements that are common to both set X and set Y. It is denoted by X intersects by Y and is read X intersection Y. Example, draw a diagram to represent a relationship between the sets. So X equals to 1, 2, 5, 6, 7, 9, 10, and Y equals to 1, 3, 4, 5, 6, 8, 10. So that's the solution. So start filling the diagram from elements in the intersection first. So first fall in the 1, 5, 6, 10 for X intersection of Y. So yung example.
The intersection of three set. The intersection of three set X, Y, and Z is a set of elements that are common to sets X, Y, and Z. It is denoted by X intersect Y intersect Z. For example, draw a Venn diagram to represent the relationship between the sets. X is a set of 1, 2, 5, 6, 7, 9. Y is a set of 1, 3, 4, 5, 6, 8, and Z is a set of 3, 5, 6, 7, 8, 9, and 10. The complement of intersection of sets. The complement of the set X intersect Y is a set of elements that are members of the universal set U, but not members of X intersect Y. It is denoted by X intersect Y. For example, suppose U
is a set of positive integers less than 10. X is a set of 1, 2, 5, 6, 7. And Y is a set of 1, 3, 4, 5, 6, and 8. Then, draw a Venn diagram to illustrate X intersect Y. Then find X intersect Y. Union of sets. The union of two sets, A and B, is a set of elements, which are in A or in B or in both. It is denoted by A, U, and B, and it is read by A union B. Combined operation. Combined operation involves the intersection, union, and the complement of sets. Perform the operation within brackets first. Other operations are performed from left to right.
Good morning, everyone. I am Mexico Menador, 18 years old, a BSIT student of GS Real Estate College University. And so for today's video presentation, I am going to give some basic information that I understand to discuss about the compound statement and negations quantified statement under the mathematical reasoning in algebra. So for further explanation, let's begin on compound statement. So, ano nga ba ang compound statement? So, statement is a declarative sentence that one either true or false. Also, it is represented symbolically by using lowercase letter and concerned only if it is possible to the sentence to evaluate either true or false. And for reminders that statement cannot be explanation or a questions. Then, so before we proceed on what compound is, then we should make study of simple statement first and then proceed to the study of compound ones. So, what is simple statement? Simple statement is conveys a single idea, and compound statement conveys two or more idea. For example, letter A, I will go in the park. So, for this one, it has a single idea, which the idea that he will go or she will go in the park. So, it has a single idea. So, this is what we call SS is simple statement. So, for letter B, I will go in the park or I will buy groceries. As usual, as we can see naman na I will go in the park is the first idea and I will buy groceries is the second idea. So it represents the compound statement. And also, let's not forget this or is a type of statement that occurs the disjunction statement. So for this one, it has a 1 and 2 ideas. It calls compound statement. So for the compound statement, I will introduce that later on after this some examples. So the first systematic treatment of such problem is found in the writings of Aristotle, and whom George Ball was the first who employed to use the mathematical methods or logical table. So as we can see, this is the mathematical methods or logical table, and this is the George Ball who was to use this kind of let's just say techniques of how to configure the types of segments. So the statement of not P is the connective of them is not, and the symbolic form is this kind of symbols, yeah, And the types of statement is negation. So, as more reminders lang, there's two types of negations, which is this one and this one. So, if you see like this one, this is the first, this is the another types of negation symbols that to be used in some other problems, the equations. So, if the P and Q are the statements, then the connective is the and the P, then this one is adjunctions, this kind of symbols. Ano ba? Ito na symbols. Then Q, that's what we call the type of statement that conjunctions. Then, if P or Q, then the connective of them is R or. Then this is the symbolic form for them, what we call disjunctions. The type of statement is disjunctions. This is the disjunctions type statement. If P then Q, then the connective is if, then parang idudugtong mo lang yung first idea, which is the P. Bali, una yung if, then the statement, then a statement, then second idea na naman, which is the Q. Then symbolic form of them is the parang pointed arrow to the right. Yeah, right there. And Q. Yeah. This type of statement is conditional. So, P if and only if Q. The connective is if and only if. Parang ilalagay mo lang yung first idea, which is the P, then on the center of the two ideas, between on the two ideas, i-add mo yung if and only if, then the second idea, which is Q, then this is the symbolic form of this one, which is parang pointed arrow dun sa left and right. Then this is called what's biconditional. So, for further, let's start on explaining. By the way, it's not okay on what P or Q be on a statement, because we can use another or some more letters to be used. Then ito nga is instructed on how to use. Pwede tayong gumamit ng kahit anong alphabetical basta nakagawa ng statement. So, another examples. Translate symbolic statement. So, the if, then yung E natin is it is raining. T is the wind blows strong. J is it will make you wet. And B is it's a bad weather. So, as I said nga, pwede tayong gumamit ng iba't ibang letter to create a statement. So, this one is E, then the connectives that they use is like this, which is what we call conjunction, and this is occurs and this is a negation of T. So we combine it into a statement E and, so the E is it is raining, so it is raining. Then the and is the conjunction statement, which we add there like this. And the wind that blows is just like this, negation of T, that the as we kanina na ang T is a connective that not. Then let's read how it is. It is raining and the wind that blows strong. So like that. So for examples number 2, J, and this parang on is this what we call disjunctions and negation of T. So J is it will make you wet. I add the it will make you wet, and this kind of statement is a connective of or. Then we put the or, the negation of T, the wind not blow strong. So parang ganyan lang, parang we'll make perfect statement to add the types of connective or types of statement. So number 3, E, then ato as we this kind of pointed arrow pa right is what we called conditional, and this types of statement is we add the first if, as we see, Then on the center of the next idea is then. Then if it is raining, then we first add the if, then it is raining, then we add also the then, because this type of statement is conditional, and the connectives of them is if and then, so we add the then the T is the wind blows strong, like then we read if it is raining, then the wind blows strong. So for number 4, T, then this one is this type of connective is if and only if, and a type of statement is biconditional. So as I said nga na, we just put the if and only if between the two ideas, which is the first idea is T. It occurs the wind blows strong. The wind blows strong. Then let's add the if and only if. Then the second statement is the letter B, which is it's a bad weather. So that's how we use the if and only if connectives. So for using statement and symbolic form using the symbols, this one is negations, this conditional, conjunction, then ito is conditional and biconditional. So our statement we have is Q, which is nail like Laika, and for R is nail like teacher, and for S is that they are happy. So the statement is if nail like Laika, then nail not like teacher. So as we remember that this kind of symbols is what we called conditionals, which the connective is if and then. So how to transform it in the symbolic form using the symbols is we put the R, which is this first idea, which is nail like teacher. So this is the R. Oh my god, this is the R. This is the R. The R, and the connect then the symbolic form, which means the if and the then. So we put this, and the negation of Q is as remember the negation symbols is not, so this is not, then their connective is not, so the negations of Q is nail not like Laika. So how we read this one? R if then negations of Q. So for ano ba to? Examples number 2. Nail like Laika and they are happy. So it's a simple statement lang naman. I know, not kind of simple statement as a statement, but it is not a simple statement. This is not a kind of simple statement. So this is the first idea is nail like teacher. So nail like teacher is the R statement, and the and is a types of connective which is occurs the conjunctions. So the conjunctions is this kind of symbols, and for this and for the they are happy is the second second statement, which is represent the S statement. So this is the symbolic form that we transform in the statement number 2. So that is for another examples. Number 3, they are happy if and only if nail like Laika and nail not like teacher. Oh, so it's a complicated statement, but you solve it by using symbolic statement. Yeah. Then i-clean natin to. So saan ba dito ang he used they are happy. So the statement they are happy is S. Yeah, as we see S. Then he used the if and only if. So if and only if, the symbolic form of that is like this. So as I said, if and only if is we add on the first and second, between the first and second statement, which is we add this, and nail like is the Q statement. So S is the they are happy, and Q is nail like and we add there's also connective, a connective of and. This type of connective is the and, remember that, and negation of R. Yeah, so here's the symbolic form that we transform. So this is a very simple statement. I know it's not a kind of simple statement, basta to be lang. Yes, it's a simple statement nga pala. This is a single idea, which so this is a simple statement. Yeah, like then they are not happy, so we use the negation of S. So number 5 examples is nail like teacher or nail like Laika. So their connectives there is or, which is disjunctions, and their symbolic form is like this. So this is the symbolic form that we transform. So for number 6, the last one is they are not happy if and only if nail like so this is the statement use not, which the connectives and it's a negations, it's a type of negations. Then they add also the if and only if, which a type of connectives that a statement called conditional. So we just put this negation of S, if and only FQ. So it's a simple ones. So I hope you had been ano ba tawag dito? Naiintindihan nyo kahit konti lang yung presentation ko. Thank you! Let's move on na negating quantified statement. So, ano nga ba ang negating quantified statement? So, negation is when you use determining the opposite of a given mathematical methods, which is mean na kabaliktaran daw ng kabaliktaran ng negations. So, also, the representation of statement is P. Then, its negation is not P. So, if ang kabaliktaran ng P statement is its negation, then the symbolic form that we use is like this, which means not P or negation of P, or also we have this one. Yeah, so the two types of negations. So as we see, it has a truth table. This is what we call truth table. So truth table is, it shows the truth value of a compound statement for all possible truth values, or it's a statement. So this is the statement of P, and erase mga ba. This is the negations of P, and this is the statement of P. So if the statement is P, then the negation of P will be false. Then if the statement is false, then the negation is true. Parang opposite lang ng kung if ang statement is false, then the negation will be true. So parang kabaliktaran lang sila. So para mas lalo natin maintindihan, ito ang example. So determine the negation of the following statement. So the statement is P, which is 6, is an odd number. So we use the negation of P, which is 6 is not an odd number. So we put lang the not is because the not is the negation symbolized. Then pwede na natin gumamit ng 6 is an even number because ang kabaliktaran ng odd number is even number. So this is 6 is an even number. So i-configure natin if true or false nga ba talaga. So 6 is an odd number, so it is a false because the odd number is conveys 1, 3, 5, 7, and 9. So it is a false kasi 6 is not an odd number. So for these two types were true because 6 is not an odd number. Yes, it's not. And 6 is an even number. So even number is 2, 4, 6, 8, and 10. So this is a true. For examples number 2, this is a P statement which is 5 is, so the statement is 5 less than of 9. So how we determine is if then the negation of P will be 5 is not less than 9. So pwede siyang isulat into what we call into statement. So what we have this is the negations of P, which 5 is not less than of 9. So pwede ring ganito. Another example is 5 greater than 9. So how we configure this into negations, which if it is true or false. So 5 less than of 9, which is true, yes naman. Then 5 is not less than 9, which is false. Yes, it's false. Then 5 greater than 9, false ito. False rin. So that's how we convert true or false and how we use negations of statement. So for number 3, the problem is 1/2 is equals on 1/5. So how we use this in negations transform is 1/2 is not equal into 0.5. So this is this kind of symbols is not equal po ang tawag niyan. So we can use like that, not equal, and it is not equal into 0.5. So which is false because 1/2 is in equals of 0.5. Parang gumamit lang tayo dito ng this is a decimal fractions and this is the fractions. So parang iniba lang yung paggamit to equals into 1/2. So this will be true and the second is false. So for the last example is the problem in number 4 is 0 is greater than 1. So for how do we use the negations is 0 is not greater than 1. So we just add a not because it's a negation form. Then for another example is is 0 is less than 1. So in transform it true or false, if 0 is greater than 1, it is not true, which is false. I-highlight ko naman ito. False to siya, guys. Then Then the negation of 0 is not greater than 1, which is true nga rin naman. Hindi naman pwedeng mas malaki yung 0 sa number 1. So, for another is 0 is less than 1, which is true. So, that will be all. Thank you.
Good day everyone, I am Laika Cheyabo, and for my topic, I will talk about the quantified statements and equivalent statements. First, for quantified statements, if we say quantified, it comes from the word quantify, which means it expresses or measures the quantity. And a quantified statement is one that says something about all, some, or none of the object in a collection. For example of quantified statements, all students in the college are taking history. Some students are taking mathematics. No students are taking both mathematics and history. So if we say something, including all, some, or no, it is considered as a quantified statement. Second, for equivalent statements, if we say equivalent, it is equal in value, amount, function, and meaning. And an equivalent statement is any language. There are many ways to say the same thing. The different linguistic construction of a statement are considered equivalent. For examples, all students in the college are taking history. Every student in the college is taking history. Some students are taking mathematics. At least one student is taking mathematics. So equivalent is a person or thing that is equal or correspond with another value. That's all. Thank you.
Derive implication rules of interference. Q arrow P converse. P arrow Q inverse. Then Q arrow P contrapositive. So, example, P arrow Q, if a car can run, then it has gasoline in its tank. So, sa converse, if a car has gasoline in its tank, then it can run. So, ang P arrow Q, ang last sentence sa P arrow Q, gikuha siya, mo siya gihimong first sentence sa converse. Then, it can run, kuha siya sa first sentence sa P arrow Q, gihimo siyang last sentence. So, mo to siya converse, gibali siya. Inverse, if a car cannot run, then it does not have gasoline in its tank. So, sa inverse, conditional statement. So, conditional statement ang if a car cannot run, then it does not have gasoline in its tank. Dayon, ang contrapositive, if a car does not have gasoline in its tank, then it cannot run. So, ang contrapositive, makita na to siya sa inverse. Ang last sentence sa inverse, kay gihimo siyang first sentence sa contrapositive. Dayon, ang last sentence sa contrapositive, dira siya gikuha sa inverse nga sa first sentence sa inverse. So, gibali ra pod siya. Role of implication in deductive interference. Number 1, role of detachment. P arrow Q, P underline, then therefore Q. So, ang underline tawag siya og happens, then ang tulo ka tuldok therefore. So, example, if you got 95 in this final exam in this subject, then you will receive a 95 as grade. Now you get 95 in the final exam, you would enter or reduce that you will receive a 95 as your grade. So, ang P arrow Q is wala pa lang siya mahitabo pa lang. So, wala pa siya nahitabo. So, ang example sa P arrow Q, if you get 95 in the final exam in this subject, then you will receive a 95 as grade. Dayon, ang P underline or P happens. So, ang example is now you got 95 in the final exam. Then, therefore Q. Example sa therefore Q, if you would enter or reduce, that you will receive a 95 as your grade. Then number 2, role of syllogism. P arrow Q, Q arrow R, therefore P and R. So P, Q, R, P arrow Q, Q arrow R, therefore P and R. So example, if it is raining, the street would be wet. Now it's raining, the street would, so therefore the street would be wet. So ang P arrow Q is wala pa nahitabo. So ang example, if it's raining, then the street would be wet. Then ang Q arrow R nahitabo na. So now it's raining. So therefore, or ang result niya or conclusion sa P arrow R, the street would be wet. Then contrapositive. Contrapositive P arrow Q, Q arrow P. If today is Wednesday, then I will go to Baclaran Church for the novena. Therefore, if today is not Wednesday, then I will do not go to Baclaran Church for the novena. So, gibali ra pod siya ang contrapositive. Then, inferring new statement. The knowledge of different statement and reasoning will help you the process of inferring new statement from already accepted statement. Example, the office of the promotion manager and lawyer are on the first floor. Mr. Reyes has to use elevator in going to his office. C. Mr. Santos and promotion manager are good friends. So, we have 3 clauses. First clause, we can infer that promotion manager and the lawyer do not need elevator to go their offices. Second clause allows to make us the statement that Mr. Reyes is neither promotion manager nor lawyer. If Mr. Reyes cannot be the promotion manager and cannot be a lawyer, he must be the actuarian. Then third clause state that Mr. Santos and the promotion manager are good friends.